Okay, so now we're on to week 2, day 1. We are going to cover a little bit of stuff from yesterday as well, but basically we have covered now everything, like on the weather side, kind of everything that we're going to start jumping into actually the charts and things now. So we're going to start by looking at kind of what was left off from yesterday, though, first. Let me see, go back to that. Okay, so yesterday I did tell you guys just to kind of focus on the METARs and the TAFs portion of that stuff. The other things that were in there are, so the METAR is a surface report. The next one in there is weather observers. So and each one of these is just kind of a little, little thing. But weather observers, just so everybody kind of knows and understands what those are, a weather observer is a person that is at an airport that has been certified by the National Weather Service as a weather observer for that specific geographic region, okay? So if you want to write this down regarding weather observers, it's just a person that has been certified by the National Weather Service, which you'll learn that there's a lot of acronyms, and you already probably know that there's a lot of acronyms in aviation, but you can just write NWS. That stands for National Weather Service. But a weather observer is a person that's been certified by the National Weather Service as basically what's the best word for it? A person that has been signed off for a specific geographic region, and typically that region is going to be the region surrounding the airport that they work at, and they are approved to give you a weather report. So they are trained on what to look for. They're trained on, being able to figure out what the visibility is, what the sky condition is, if there's a ceiling, trained to be able to, read the wind, to read the altimeter, and obviously the temperature. What's that? We got 3 people who do that. Okay, see, I was wondering about that. So St. George does have 3 weather observers?
Yeah, Keith Off is one of them.
Okay.
So Keith, Dora Mills, and Margie Kira.
Okay. That's good to know. Yeah, so a weather observer, typically you're not going to see weather observers except for in places that do not have air traffic control towers, because like people that work in the towers are all certified weather observers automatically just by their job definition. If you're an ATC then and you're at a specific airport assigned, then you have to basically become a weather observer for that airport in order to be air traffic control for that airport. So that's kind of automatic. But the only places you normally see a person that's a certified weather observer, outside of somebody that's in ATC or something like that, is going to be places that don't have air traffic control towers. And the reason why you need them is going back to like the METAR and the ASOS machine. So if you don't have a tower, then you're always relying on that ASOS or AWAS machine that's just there, and those things malfunction all the time, all the time. I'll try and see if I can find like pictures of like what they look like and stuff, but an ASOS and an AWAS, you maybe have seen, if you're out on the airport, it's like a little, you'll see like a little area that's kind of like fenced in, and it's got all these like little weather instruments inside of it. It's got like a little pole with a wind thing, and it's got like a little camera that like shoots out a laser to do visibility. It shoots one up and it shoots one out, so like visibility going horizontally and then vertically, and then it measures the sky ceiling and things like that as well. So it has all this instrumentation in it, and it basically feeds the weather report basically. But those things malfunction all the time, and even like little things like a bird comes and lands on one, and it'll totally screw it up. Like it'll come and land on that laser that measures the visibility, and all of a sudden, like St. George, which is, you're physically here and you can see, oh, it's, definitely 10 miles visibility, sky's clear, but then all of a sudden you'll see like a METAR report or a SPECI will come out and it'll say quarter mile. And it's just something, sometimes it's just something stupid like, oh, like there's a squirrel crawling around on it, It can be any like little thing, or they can get bumped. And then because there's all these instrumentation in it, sometimes one of them fails or one of them breaks, and then all of a sudden it doesn't give you the ceiling, or it doesn't give you the visibility or the wind, or one of those 5 things that's required ends up missing. And if that happens, like I was saying earlier, it makes it so you can't launch a flight. It literally handcuffs you completely, even though you can walk outside. A pilot can be standing there, and this happens literally with the amount of flights we do. We obviously see it more often, and due to the fact that we fly to so many places that are non-towered airports, we see it probably more than most airlines. But it probably happens at least on a daily basis for us. At least one place, one time per day, at least as far as SkyWest is concerned. So we'll have a crew that will call and say, I don't get what the deal is. I mean, I can tell you myself that it's 10 miles, sky's clear, because I can see I'm here. But even with him saying that, due to the fact that he's not a certified weather observer, he can't make that call as far as telling you what the weather is.
So what if you had a certified weather observer that was also a pilot? Would you be able to be like, yeah, I'm good, and go ahead and land?
Well, the problem is this, okay? So certified weather observers, they are only certified for the geographic region that they work in. So it would have to, if it just happened to be that you had a pilot that happened to be a weather observer for where he was, that's going to be where your problem is if your pilot is a weather observer, it has to be where he's at. So,
So it's here,
mm-hmm.
and something happens with the guitar, you'd be able to call St. George and talk to either Keith or Margie and be able to say, hey, can you verify this for me, and then we could go?
Yeah, we'll call one of them up. They'll walk outside, and they will give us a weather report. We'll write it down, and we will use that as an official report. Because if it comes from a weather observer, it then becomes an official report. We can use it. But we have a lot of.
They have to do 6 weather observations a month.
Yeah.
Each time to stay certified and recurring.
Yeah, that sounds about right. The majority of our airports do not have weather observers, though. So if the ASOS is broken, or if it's missing any of those 5 things, then we're as good as grounded. So we can't launch, or if we have a plane there, it's stuck there. So we end up having to call.
Comes out, or
well, if the thing is, if the ASOS is broken, then typically whatever the METARs that come out, they're all going to, until it gets fixed, every single METAR that comes out is going to be missing or be incorrect from that point forward. So we have to wait for the National Weather Service to send out a technician and fix it. But sometimes you'll see, we'll go like a span of like 5 straight days, like where we have to set up like a fuel stop type situation or an overfly. One really common one, those of you that work with and know the cities, but that Minneapolis to Hibbing and then goes to International Falls. It's like that little milk run flight. There was, like last year, there was a span of like a week or 2 that the Hibbing ASOS wasn't working, and we just, every single day we just overflew Hibbing and just we'd go straight to International Falls instead of stopping in Hibbing, and then we would bus the people down. So it happens all the time though.
These observers,
Mm-hmm.
are they like on, I mean, is that like public record, I guess, on who the observers are for that specific airport? Can any airline just research that or look that up for who the observers are for that specific airport to call? Or do you just have to know, I guess?
Well,
does that make
what
sense?
we
Is there a
do,
list?
there's a list, and the list resides with the National Weather Service. So if you ever needed to like verify the list, you'd have to call the local National Weather Service office for whatever airport. Now, what we often end up doing is we end up just calling the airport and asking them if anybody's a weather observer, and we just kind of go off of their word. So if they say they are, then they are. We get into situations like in Cody. And the thing is, I mean, if it ended up getting audited or if they ended up getting caught, I mean, which is probably unlikely, but it basically would obviously fall back on that person, and then obviously every one of our calls is recorded. So it, as long as we're doing our due diligence and they're going off of the trustworthiness of that person. But there's been situations before where we have found out, like in Cody as an example. I had a situation last year where I don't even remember what was going on with the ASOS, but one of the things wasn't working, so we needed a weather observer. However, the person that was the weather observer wasn't on the clock. So a lot of times, if they're not working, then they got to like call them, and they got to come in and do a report. And so we were waiting and waiting and waiting for this person to come in, and we kept calling her, and she's like, oh yeah, I'm going to be on my way, but it was like taking like hours, it seemed. Anyway, she finally called back and just gave me a report on the phone. And so I took the report and I was like, okay, great. And so I put it in and used that. But then I don't know how it came about, but like a few minutes later, I ended up talking to like the station again. And typically the weather observer works for the station, just so you guys know. Sometimes they work for the airport ops authority, but typically they actually work like for the actual station, like in like Delta Ops or United Ops or whatever. So ended up calling, and then they said that I can't remember. Oh, that's what they said. So they called me and they said, oh, and so and so, say Jessica just called me and told me that she'll be here in about 15 minutes. And Jessica is supposed to be the weather observer. But she had just called me and given me the report just a few minutes ago. I'm like, well, she just called me and gave me the report. And then it's kind of like that person realized that maybe she just, kind of,
Outed Jessica?
I guess. And so we ended up realizing that Jessica gave us the report, like, from wherever she was, maybe at home or whatever. But anyway, so stuff like that. It's kind of happens, yeah. I don't think anything became of it, but either way, they're supposed to be at the airport right there where they can walk out and see stuff. It all really sounds kind of dumb, especially when, like you've got people there that can see the weather, and like even like if the plane is over St. George and the ASOS goes out, even if they can see the runway, like literally look down and see the runway, if it is not reporting, they cannot land. So there's all sorts of these little things in the FARs that you'll learn about that are really kind of just really weird little things like that. So
That's overridden if they've already started their descent and goes down, right?
no, if it goes out before they land, then they're not supposed to land, basically.
Okay.
So even if they can see the field, they're not supposed to land.
This might be a question that's unnecessary, but like, who repairs those ASOS machines? Like, is there somebody specifically here in St. George that goes out to fix it if it breaks, or do they have to send somebody from Vegas or Salt Lake? Or
So it would be the nearest national weather. It would be whatever National Weather Service office that St. George belongs to. So they just have technicians that work in their offices, and they send them out. But it's almost, unless it happens to be in the city that it happens to be that their office is in that city, then usually it's always going to be like the next day or maybe 2 days or whatever.
I imagine they wouldn't have an office in a small outstation.
Yeah, not
Places that
typically.
have a tower that they have.
Yeah, not normally. So,
Just curious.
yeah. So that's what a weather observer is. ASOS, AWOS. So that's obviously the equipment at the airport that actually gives you the weather reading. And then there's all sorts of, well, there's not a ton of different types, but there's different AWOSs, and there's ones that are called AWOS and ones that are called ASOS. Ultimately, they're really the same thing. You might see it called the different, one of those two different things, automatic weather observing system. And then the other one is, I don't know even what the S stands for on the other one, but it's basically the same thing, automatic whatever observing system. Not really something that you've got to know, obviously I don't know, so, but just ASOS, AWOS, and then, within those there's some that have different functions, like some of them can actually disseminate like the different types of precipitation, like whether it's snowing or whether it's raining or whether it's hail or anything like that. Some can do that and some cannot. And so you'll see like little remarks at the end of a METAR report that says like AO1 or AO2, and that basically is just telling you that it's a certain type of an ASOS, which does not give you, either it does not give you precipitation or it does give you precipitation, basically. And that's the most common difference between different ASOSs that you'll see, is one that does give you precip and the other one does not. So like, for instance, here in St. George is a prime example. This is an area where it's typically always dry, and so when they originally put in the ASOS system here at the new airport, they did not get one that did precipitation. It couldn't disseminate precipitation. And so when it would rain here and things like that, you would never actually see that in the METAR. You would just see, you'd see your viz, you would see your wind, you'd see your sky cover. But if it was raining or if it was snowing, like a couple of years ago when we had that massive snow, the METAR here at the airport the entire time was just reporting quarter mile, overcast, 100. So it never actually was reporting snow, heavy snow, anything like that, ever. Even though, the airport and the runway ended up just getting socked with snow, and they closed the airport for like a day and a half because of the snow. But the ASOS never said that it even was snowing. Now, they have since upgraded the ASOS here, and it now does do precipitation. But just that's, if you're ever looking at a METAR report and you're wondering if, you're sometimes you'll see like a big, like you'll look at the radar on your satellite radar stuff, and you'll see that there's like rain that looks like it's over an airport, but then you look at the METAR and it doesn't say anything about rain or snow. Sometimes you just want to look at the very end of the METAR and see if it's like an AO1, and then that'll tell you, well, even if it was snowing, you're not going to know because it doesn't have a precipitation discriminator, is what they call it. So, but in general, ASOSs, AWOSs are just your systems at the airports that give you those automatic weather observations. And they break all the time, and yeah, that's pretty much most of what you need to know about them. The other thing there, so significant en route reports and forecasts. That is speaking of, I'm going to transition over here to, let's see here, where is it? I'm going to bring up our lovely weather thing. bring it up over here. I'm just going to I should have brought this up before. Okay. Okay, so in here we have so this next part where it talks about the significant en route weather reports, those are referred to as segments. S-I-G-M-E-T, segment. So what segments are is they are reports of conditions that are actually occurring, or basically it's kind of an area where hazardous conditions are occurring or potentially occurring. So there's kind of those two keywords with this in a segment, and this is something that you do want to know here. So a segment will be a defined region of hazardous weather, and what they do is they end up showing you like a segment like on a box, and I'll show you exactly what it looks like. So when I come in here to the weather, you can see on this right here, you can see that there's an actual thing here that says segments. Can everybody see that pretty good on here? Mm-hmm. So this thing says segments right here. Now, if I go into this, today is overall a pretty good day as far as segments go, but it's not showing any. So but to show you the different types of like segment, just to kind of give you an idea of what they are and what they report about, segments will show you, so there's the different types of segments that you can get are going to be, coming back into this, so you can get them for like dust storms, you can get them for volcanic ash, you can get them for icing, you can get them for turbulence. Those are going to be like the most common ones that you'll see. And then, so what it is ultimately, and then let me go back into this other one here real quick. Then there's another type, which is still a segment, except it's called a convective segment. Now, a convective segment is just simply talking about thunderstorms, okay? So if you hear segment, that's talking about all of the hazardous weather except for thunderstorms. And then when they're specifically talking about thunderstorms, they will call it a convective segment. Now, when I bring up the convective segments, you'll see that indeed there are some of those out there right now. And this is kind of the same thing though. I'm going to zoom into this one over here. If I can get a little bit better. You guys can all see that good on your screens. So this is obviously up over the state of Washington, but there is a convective segment up there right now over Seattle. And basically what it is, you can see kind of how it's drawn out like that, but it is a defined area or region, and it'll look just like that on a map, of hazardous weather. That's kind of what your definition of a segment is, okay? Now, depending on, what type it is and things like that, they're usually, different colors and stuff. Now, this happens to be a convective segment, so this is basically saying that the hazardous weather that's in this area is going to be thunderstorms. Now, if it were, icing or turbulence, there'll be different colors, but it'll actually tell you that this is a turbulent segment, this is an icing segment, this is a dust segment, and you can just kind of think, like where, you see these different types of segments. A dust segment, you'll see those a lot of times, like over Arizona, over New Mexico, over West Texas. You'll see these big dust segments where you get those huge dust storms. Dust storms are also, for whatever reason, called haboobs. Has anybody ever heard that? So, if you ever hear people, obviously in the office, they love to have fun with that word. So,
Everybody likes a good
of course. So, you'll see, segments for dust storms. You'll see them for turbulence. I'm actually really surprised that there's no turbulence segments out there right now. So this chart that we're looking at is only going to show us convective segments. The one that I went to before that was blank is showing you any other type of segment. So right now, the only type of segment that we have anywhere in the U.S. is convective segments, and there happens to only be 2 of them. This one that's over the state of Washington. See, that's the regular segment chart, of which there are no segments, no dust, no icing, no turbulence, no volcanic ash, obviously. Let's see, this will go back up here.
Normally you'd see some turbulent segments.
Yeah, this time of year you do normally see turbulent segments. And as far as convective segments go, there's only 2. There's this one over the state of Washington, and then this other one over the East Coast, running South Carolina, Georgia, over into Florida. So, and you can see this one here. It's basically, this doesn't zoom in all that great, but you can see the yellow in here. It's just a line of thunderstorms that extends through that area. And they have these different names, like this one is called 1-7 Echo. But they're basically just referring to, the E will refer to, the region that it's located in. That just means it's on the east region. And then it's convective segment number 17. But every 4 hours, they're supposed to update, and then they rename them. So that's not really a huge thing that you need to know too much about that. But just need to know what segments are and the different types. So the National Weather Service is the one who issues segments, and just depending on what kind of hazardous weather they're encountering, they'll issue a segment for a certain area, and it's basically just telling you that that you can expect, if you are a pilot and you are flying through that area, or if you are a dispatcher that's planning a flight through that area, you might potentially expect to see that hazardous weather, whatever segment they're associating it with: turbulence, ice, dust, convective, thunderstorms, volcanic ash, whatever. So that's what a segment is. It's hazardous weather. Now, a segment also is considered significant weather. So it's considered to have a significant hazard. Okay. There's also another type of this exact same thing out there, except it's called an airmet. Okay, you need to know what an airmet is. An airmet is essentially the same thing as a segment. The only difference, though, is that it's not necessarily considering it hazardous. It's kind of a segment, but to a much lesser degree. And typically airmets are going to be more for like really small planes. Like, not that it's only for them, but they're the only ones that are usually going to be interested in airmets. Generally speaking, like as a large airline, or a large plane, even our planes, which are the smallest of the airline planes, essentially, we typically really don't care too much about air mets. It's really more for like your little Cessnas and your, those are the ones that it's going to affect more. But I'm going to go back here to the air met page, which is this one. You can see out there are a lot of air mets. Now they're all different colors, so this kind of gives you an example of what I wanted to show you on the Segment page. But it has all different types of colors out here, and it'll kind of tell you what they are as you go around here. So like this one that's over Washington, this is an icing air met, and it says moderate ice from 12,000 feet to 20,000 feet. But once again, though, it's not necessarily anything that large aircraft are going to be too concerned about. This air met out here, this red one, that's an air met for IFR weather. And IFR weather just simply means like low visibility or low ceiling, like fog or anything that's going to reduce the visibility or the conditions around an airport. So if you look at that, there's a big long air met along the entire west coast essentially, and that is for potential IFR conditions. Now, just because there's an air met out there, or a SIGMET for this matter, it doesn't necessarily mean that it's occurring everywhere inside the box. It just means that it could potentially occur anywhere inside the box. It doesn't necessarily mean it's actually occurring. Now, in some areas, it will be actually occurring. Usually, in order for it to even exist in the first place, it had to have been actually occurring somewhere in there. But it doesn't mean that it's necessarily always occurring everywhere inside the box. It just means that if you're flying anywhere in that box, you might see it, you might not. Okay? And that, later on, you'll learn that that ends up kind of playing a very important role in flight planning. Just the fact that that's the way it's defined, but we'll get more into that later. And then obviously there's other ones over here for like there's a lot more air met types than there are SIGMETs, but ultimately they're a lot the same. So IFR, does everybody know, has everyone heard the term IFR before? IFR just stands for Instrument Flight Rules. That means if you're flying a plane in that area, you need to be an instrument-rated pilot. Okay, instrument just means that you know how to fly the plane without being able to see out the window. You can fly it solely based on looking at your instruments and your compass, your navigational equipment inside the airplane. If you are a VFR pilot, then that means that you fly under visual flight rules. That's what VFR stands for. But visual flight rules, you're only authorized to fly in conditions like we have outside right now. And there's a specific, there's basically a level of where VFR officially changes to IFR, what that actual term is, or where that, what specific weather defines the difference between VFR and IFR. Well, first of all, you have VFR, which is nice day outside like this, and then you have another category that's called marginal VFR. Marginal VFR just means that you've got some clouds moving in, you might have a ceiling, and a ceiling essentially, for those that haven't seen it yet or don't know, a ceiling is just a cloud layer, when you're talking about clouds, and when you went through the cloud section, you saw that there was, a lot of different, with cloud coverage, basically, there's different types of cloud coverage. You have few, you have scattered, you have broken, you have overcast. I don't think I'm missing any. Scattered, few, broken, overcast. But they basically go, so on a clear day you have skies clear. If you have just a few clouds in the sky, then it'll be reported as few. And then it'll tell you, the altitude that they're at. And then you have scattered, and then you have broken, and then you have officially completely overcast. So in terms of a ceiling, and this is something you want to know here, a ceiling is a layer of broken or overcast clouds. So only broken and overcast are considered to be a ceiling. If you see a report that says few at 10,000, few wouldn't be considered a ceiling. Scattered is not considered a ceiling. It just is broken and overcast. So in order to have a ceiling, it requires having the broken or the overcast layer. And once you get down to like 3,000 feet, like if you have a broken or an overcast cloud layer at 3,000 feet or below, that's when you're considered marginal VFR. And then if you get down to where that ceiling is 1,000 feet or below, that's when you like officially enter IFR. Okay. The actual difference in the definition between those two isn't necessarily something, I mean, you'll eventually just know that, but it's not necessarily something that you're going to be grilled on in here. As far as the ceiling, the definition of a ceiling, that is something you definitely want to know. And once again, that is just, if somebody were to ask you, what is the ceiling at a given airport, you would look up the METAR and you would see, first of all, if it even has a broken or an overcast layer in the METAR. If it doesn't have one, then the airport doesn't have a ceiling at all. If it does have a broken or an overcast layer, the ceiling, the official ceiling at that airport is going to be the lowest layer. Okay, so it is the lowest layer of broken or overcast. So if you want to add that to your ceiling definition, it's going to be the lowest layer of broken or overcast. Because you'll often see a METAR report that says broken 900, overcast 1,000, overcast 15,000. Sometimes you'll see 3 or 4 different cloud layers in there. And if any of them are broken or overcast, your ceiling is going to be whichever one of those is the lowest one. And typically the way it's going to report is after you have your visibility, the next thing in the METAR is always the sky condition. It usually, and I think always, should always list the lowest clouds first. So if the lowest ones happen to just be like, if there's a few clouds at 800 and then a scattered layer at 1,200 and then an overcast layer at 2,000, it'll always go from the lowest clouds to the highest clouds in the order that it lists them in the METAR. That's how it should, at least, unless it's broken. But that's not usually something you see break. But that's the way it lists it. So just always look for the lowest broken or overcast layer. If it's anything but broken or overcast, it's not a ceiling. So yeah, IFR conditions. So it's basically saying that the coast of California, anywhere along there, could experience IFR conditions. So the other part of IFR obviously is the visibility. Once you get to 3 miles visibility, that's when you officially transition from that VFR into marginal VFR. And then from marginal VFR to IFR would be down to the 1 mile. So 1 to 3 miles is considered marginal on the visibility. 1,000 to 3,000 on your ceiling is considered marginal. If you're over 3 miles and you're over 3,000 feet on a ceiling, that's considered VFR. If you're below 1,000-foot ceiling or 1 mile visibility, that's when you're considered IFR. So, like I said, the actual transitioning between those all, you don't really need to know. There's more definitive 121 rules that actually narrow us down a lot more on, kind of pin us down on more on our rules that we're going to care about later once we get into it. But as far as like air meds and things are concerned, that's the only reason I'm really mentioning is so you can kind of get an idea of what it's talking about when it's issuing an IFR air med. But it's basically saying anywhere along the coast of California could experience ceilings of less than 1,000 feet or visibility of a mile or less. So, and we see that all the time, coastal conditions, especially at night. You get your San Luis Obispo, your Santa Barbaras, your Monterey's, anything that's along the coast at night when the sun goes down, and it goes back to that same process that you guys just learned about with the fog and things and the advection and the radiation fog. Sun goes down, the water temperature stays higher, and then the land cools down, obviously at a faster rate than the water, and due to that process happening, the wind then shifts back to a land breeze, and you get, as soon as that breeze hits that warm water, cold air over warm water creates the fog. The fog then moves right in over the airport. So that's why it happens right when the sun goes down. That's kind of, and it does happen obviously during the day too, but the most common thing to see is the sun sets and the visibility drops. That's usually your most common thing that you'll see in a coastal airport. And a lot of it's unexpected too. So a lot of it's unforecasted. Your diversion from, you got a flight going to Santa Barbara that, oh crap, Santa Barbara just fell. It was not in the forecast. It wasn't in the TAF. And all of a sudden, it just drops. Just unforecasted fog or whatever. So you'll also learn going along and later on that the forecasts that we get are very highly unreliable. In fact, I think in one of those movie links that I put on there, I think it even said that forecasts are only right as often as they're wrong. So it's like 50-50. So as a dispatcher, you end up you end up becoming very familiar with airports, obviously. You end up dispatching to the same airports over and over and over and over. You end up getting familiar with their trends of what they do at night. And so as a dispatcher, you start looking at things more than just the forecast. The forecast might say that it's supposed to be VFR all night long at that airport. And based on just looking at the forecast, it may not, it may not tell you, or it may not make you think that you need more fuel or need to add an alternate. But then you start looking at other things. You look at the wind direction. You look at the temperature dew point spread. You start looking at, the satellite layer of other clouds in the area. I mean, you can look at a whole number of different things. And as a dispatcher, you'll often kind of come up with your own forecast in your head. And a lot of times you'll kind of say, I don't know if I trust that forecast, or I don't know if I buy what that forecast is saying. And then you'll just end up adding fuel and an alternate, even though the TAF doesn't, quantify it one bit. And then, a lot of times you'll end up being exactly right. Whatever the airport it is will end up just totally falling to pieces and going below landing minimums and end up diverting and, pat yourself on the back sometimes. But then a lot of times you add extra fuel and then it does do, what it said it was going to do, and it stays good all night. So, like I said, it's really a 50-50 process, and it's like that with a lot of different airports. Anyway, those are air mets, but like I said, air mets are really only a greater concern for aircraft, for light aircraft, light, private, non-commercial aircraft. if you have a turbulence air met, a turbulence air met is really not going to affect, like when you think of turbulence in an aircraft, even just the little light chop stuff. I mean, that obviously is going to affect a little aircraft a lot more than it affects a big plane. So if you see a turbulence air met, in fact, most people at SkyWest don't even have their air mets turned on. You can't even see them because they really are meaningless. The only time you ever really even look at them is if your aircraft has, if it has a, and we'll get into systems later, so don't worry too much about what I'm talking about, but let's say it's an aircraft that has a maintenance issue, and that particular maintenance issue says that this aircraft cannot fly into icing conditions, okay? I know you guys have all heard that before, but if I have a plane that cannot fly into icing conditions, that would be something where I would go in and turn on my air mets, and I would be looking to see if there's any icing air mets. Now, in that case, an icing air met would affect you just simply because your aircraft does not have anti-ice capability. So, but on a normal basis, when everything's functioning and your plane has, all systems operating, you could care less about an icing segment, or not a segment, an icing air met, or a turbulence air met, or any air met really. So, in fact, I would venture out to say that the only air mets that you'll probably ever care about in any situation would be an icing air met, and that would only be in the situation that you have an aircraft that has lost its anti-ice capability. So, just so you guys kind of know where we're at with air mets. Now, if it's a segment, segments are designed and they are more specifically trying to kind of dictate themselves to the larger aircraft. Icing, if you have an icing segment, that's going to be extremely significant to you. Really any segment, turbulence segments, it means that if you have a segment for turbulence, that means that the turbulence in that area inside that box is pretty significant, almost to the point that as a dispatcher you may even want to completely file them or plan the flight to avoid the box. Now you can't do that all the time, obviously, because sometimes you get turbulence segments that just literally span the entire north to south. You can't avoid it, basically. And you'll see inside of those, you'll see, you can kind of see, the areas that are worse, and that are better and worse. And sometimes a different flight level, like sometimes flight level, up at 36,000 feet is a better ride than, say, 28,000 feet, or it can be the opposite. 28 is better than 36. It doesn't really matter as far as that goes, but a turbulence segment is going to mean that the rides, for passengers are going to be pretty uncomfortable through that area. Typically, it's going to be pretty significant, moderate turbulence. Now, you do get into other things like where you have severe turbulence and things like that. That happens a lot as well, and you'll see several severe turbulence PIREPs, and we're going to get to PIREPs here in just a minute. But PIREPs are, just reports specifically from an airplane, but you'll see several reports of of severe turbulence inside turbulence segments. Icing segments, you'll see that means that that the icing through that area is very, significant enough that even an airplane with anti-ice capabilities would have need for, for pretty good concern. We'll talk a lot more about all of these segments later in flight planning, but just to kind of give you an idea, the worst segment out there from a dispatcher perspective, and even, from a pilot perspective, the worst one is probably icing. As a rule, And we'll get the same thing with this. We'll get into this more when we touch back into the FARs, when we go back to them, and then the flight planning. But if you have an icing segment, you technically cannot even dispatch an aircraft through that segment unless you have valid reports that the area that you want to fly through does not have icing that actually is occurring. You don't necessarily need to write that down right now because like I said, we'll go into that later, but just to kind of stress the significance of an icing segment, you can't even dispatch through it unless you have special reports to actually document on your release that says that the icing is not occurring where you want to fly. Otherwise, if you don't have that, you can't even go inside the box. So if you were to take, let's just say that red box here, let's just say that was an icing segment. You wouldn't be able to send a plane anywhere inside of that box if you didn't have, the special, report that says that it's not happening.
How common are those?
Icing segments in the winter can be, it kind of is one of those things where it like just goes in waves, but like you'll have like a whole week of like where you just have a huge icing segment that like just sits over like Colorado and Utah, and so some is worse than others. This last winter, it was not really that bad at all, but some winters you'll see like an icing segment that like literally that is the size of all of Utah and Colorado. It's usually more in those mountainous regions that it occurs, but basically the amount of icing going on inside of a segment, in order for it to actually qualify as a segment, it would mean that an aircraft that's going through that area, if an aircraft is encountering severe icing, and let me just put in a little plug too. When you have anything that's a segment, right, whether it be a turbulent segment, an icing segment, a convective segment, dust segment, any of them, any one of the segments, it means that the weather that is associated with that segment is considered to be in the category of severe, okay? So if it's a turbulent segment, it means that there is severe turbulence. If it is a icing segment, it means that there is severe icing, which is obviously the worst you can get from a reporting standpoint. When you talk about severe icing, though, severe icing would be like icing so bad that even a plane with anti-ice capabilities is not able to keep up with the amount of ice removal or ice melting, basically, on the wings and the engines. So just to kind of give you an idea. So with icing is like literally the #1 worst aircraft, the worst weather or the worst weather-related thing that you can have occur onto an aircraft over anything else. Icing is going to be your #1 most common thing that you want to avoid more than any other thing. So keep that in mind. But icing, yeah, so that's why if you are dispatching an airplane through an icing segment, you have to be able to document that, let's say another plane that just flew through there, you could send, some other plane in ACARS, and they can message you back saying, yeah, we did not pick up any icing in this area, because the thing is about an icing segment or segments in general is that it obviously takes a plane having it happen to them to even be reported in the first place, right? So you have to have a plane or two or 3 or 4. Usually it's several aircraft within a region that are reporting the same weather phenomenon. So it's not just going to be like one aircraft that flew through over the Rockies that called into ATC and says, oh, we've got severe icing going on. They're not going to issue a segment for just one. It's usually going to, I don't know the exact amount, but it's usually going to be like probably 5 or more aircraft that say the same thing. Like, okay, well, this guy said he's got severe icing. Now this guy says he's got severe icing. And kind of based on the reports that ATC starts getting of people reporting that weather phenomenon occurring to them, they start to kind of map it out, you know, and that's where they get their little boundary from, and then they just, oh, well, this square is what we're going to call the icing segment, you know. And from the point that they issue that segment, if it's an icing segment, it then literally, like on a segment, on an icing segment, it's going to be red usually. You can actually, you know, as a dispatcher on our programs at work, you can change the colors to whatever you want. I personally have it as red, just signifying that do not enter the box, you know, it's a red box. So, or, you know, you guys get red boxed, you know, at work. I know that. I hear that all the time. The equivalent of getting red boxed on dispatch is having an icing segment popped up. The only way you can enter the box is if, you know, it's the same way that the segment got issued is by people reporting it happening. Well, then you also have to have people reporting it not happening in order to fly that route. So if you're gonna, you'll have your map routed out of where you want it to go, and you have to basically solicit reports from other planes that are currently flying through that area, or even if it's another airline or whatever, if they issued a PI rep, you know, a lot of times you can get that information, and then you can use that to you know, validate your own release for your plane to fly through there. So there's a lot of different situations here. It can be a plane that you have that hasn't even left the ground. Let's say that you are dispatching a plane from St. Louis to San Francisco, and it's already in the air over Kansas, okay? And all of a sudden, while it's in the air, a big icing segment pops out right over Colorado, right in its line of flying that it's going to, you know, cross over. Well, if that happens and you don't have reports of, you know, if the icing segment pops up, you then need, in order to enter the box, basically, you now need a report saying that that line that you're going to fly does not have icing. So until you get that, you basically have to plan that that person would either have to veer north or south or go around it. Typically, it's not a big problem. You'll usually get your reports. We have enough airplanes in the air at any given time just to, you know, if a box pops up over Colorado, you know, usually, you know, SkyWest probably has more planes in that box than probably any airline, you know, just simply with the amount of flying that we do. So for us, it's usually not a problem. We can usually just ACARS a plane that, because, you know, if they're already in that area when the box pops up, well, there's nothing they can do about it, you know, at that point. It's just that if you're not already in the box, you can't enter it. So yeah, you got to verify in order to go in. Now, if you got a plane that's already in it, you can message them saying, hey, icing segment just popped up right over where you're at. You know, what are you seeing? You know, and then they'll report back, oh, no issues for us, no icing, at least in that part of the segment. And then as long as your plane is planning on flying that same part, then you're okay. You can actually send a message to your crew or put a note on your release if it's a plane that hasn't left the ground yet, letting them know that they can go through that area. Let's see. So that's icing. Turbulence, you don't, you know, icing is the only one where you would need to do something like that. Turbulence, obviously, you're going to want to try and avoid turbulence as much as you can. At the end of the day, you know, you as a dispatcher, your primary concern necessarily isn't, is passenger safety, obviously, and just safety in general is the number one concern for dispatchers. So with that in mind, you know, you obviously want to avoid severe turbulence, because if it is a turbulent segment, it means, like I said, it means that it's to the level of severe is going on somewhere inside of what they're calling the segment. Like I said, it doesn't necessarily mean that it's happening everywhere inside the segment. Same with icing, and same with any other segment. But it means that it could potentially happen anywhere inside the segment. So, and then obviously the easiest ones to see as far as if something is actually occurring, convective segments with thunderstorms are obviously going to be the easiest thing from a dispatcher perspective to actually be able to see, okay, well, I have this area that's a convective segment. You'll be able to see where your thunderstorms are at. but that's the only one that you can see is the convective, just simply from radar and things like that. You can see where a thunderstorm is at, but any of the other Sigmet weather you can't see. So it's kind of one of those things where icing, you can't see where that's happening. It's not going to show up on your radar. Turbulence, same thing. The dust storms, volcanic ash, things like that, those are not going to show up. The only one that you can ever see is obviously a thunderstorm. So if you see a convective Sigmet, you can clearly say, well, this whole part of the Sigmet doesn't have any thunderstorms, and you can report that, to your flight crews and things like that. But once again, though, convective Sigmets aren't something that you need, special reports to go through. The only one you need with that applies to is icing Sigmets. So that's Sigmets. I'm going to cover PIREPs real quick, then we'll take a break. But PIREPs, I've already been talking about it, obviously, but PIREP is just short for pilot report. And PIREPs are very important to the aviation world because it's a representation of what is actually occurring in a given area at a certain flight level, whether it be turbulence, whether it be icing, whether it be anything weather related can be reported into a PIREP. It's basically where ATC gets all of their information from as far as what flight levels are the best to keep planes at. ATC and like flight crews are always talking to each other about, well, how's your ride through this area? How, or the flight crews will solicit ATC saying, hey, at 34,000 feet, we're getting some moderate turbulence. Do you have any reports of a better altitude? And then ATC will come back on, yeah, everyone's been saying 360 or 36,000 is better. So, based on that, they'll go up and down. And then as far as what a dispatcher sees, if a pilot or any airplane issues a PIREP, you'll actually see it on your screen. In fact, let me go to the PIREPs. Let's see here. Can't remember if it's in this. Let's see here. Okay, PIREPs. So this right now is a map of all of the current PIREPs. So PIREPs typically will show up on your map like this for about 30 minutes and then they'll disappear. So PIREPs really only valid, and you can change your settings and stuff, but in general, PIREPs are only valid for 30 minutes and then they'll completely disappear. So let's take a look here. So I'm just zooming into this area here. Let's see, so this here is going to basically be a PIREP for, this is just a ride report basically. So you can kind of see down here the difference between what they're showing here. So this green one, which is these two here are green, that's at 38,000 feet, no turbulence is what they're reporting, and then it also does report the wind there. We won't get into that wind stuff yet, but you can see this one up here over Nevada at 35,000 feet. There's no turbulence, but then you see the little icing thing here of the yellow. That means there's some light icing, no turbulence. So you can kind of get an idea of what they're reporting in PIREPs, and then we'll also kind of look at, let's see here, see if I can bring up the go back. Okay, so over here in this area, up here over Wisconsin, we've got some moderate turbulence up in here. Over here, light turbulence, you can see, the color coding here. So these arrows, this thing that's attached to the PIREP report, this is basically a wind report here. So when you're looking at these little triangles are basically your wind speed. So when you're looking at this, like you see 4 triangles here. Those all are, let's see, I believe those are 25 knot. So that's basically saying that the wind right in this area is 100 knots. So every little triangle you get is basically 25 knots of wind speed. So it's basically saying, and then the direction that it's pointing. So it's pointing northeast. So the end of this end is, so the far end is always going to be where it's basically coming from, and then the wind is blowing to the northeast. So if you're looking at a station or where a PIREP is, if the PIREP's over to the left here, that means the wind is blowing from the left to the right, basically from the west to the east. And then if you count the little triangles, that's going to be 25, 50, 75, so 100 knots even on this one. This one down here, 75, 76, 77, 78 knots. And this is at 320, so 32,000 feet. Does everyone kind of understand how they list flight levels and things like that? So if you see like a 320 or a 180, those are always listed. Those are basically listed in hundreds of feet. So any of these that you see here are going to be, so like 320 will mean 32,000 feet. Over here 290 means 29,000 feet. This one right here 450, 45,000 feet. Right here 180. When you're looking at like your METAR reports and stuff, and you'll see broken 008. So the furthest to the right column is going to be your hundreds, basically. So 008 would be 800 feet. 010 would be 1,000 feet. And then 100 would be 10,000 feet. But just want to make sure everybody kind of understands how those are listed, that there's no issues. You're going to end up seeing those reports enough where it just becomes secondhand when you're looking at it. But altitudes are always listed just like you see it here. They're always going to be the 3 digits, and it's always going to be in the hundreds of feet. So you just, whatever it's saying, you're going to times it by 100 essentially. So but PIREPs are important. PIREPs are basically telling us everything that's going on, on a given route, and they can be for anything. Turbulence, icing are the most common, obviously, like you see, but they give you the wind speed through a given area. They give you wind shear. They give you all sorts of different things, and we're going to look plenty at them going on later in the class, but just to kind of give you an idea of what they are, and they're just pilot reports. That's what it stands for. And I'm going to bring up a textual.
Really quick, Adam, on those directions that you were saying on there. Is that just kind of like a gradient in Mustang where it's going that way? So with the one example that you were saying, it was going that way, so sorry, it was going this way, so it's this direction, so it's getting bigger the direction it's going.
Yeah, well, so It just basically means like if I have, let's see here, bring this up in Paint. This is a request from Ashley. She was saying, instead of drawing it on the board where nobody can see, if they're watching this, you know, if they go back and watch it, do it where we can see it. And I'm like, yeah, that's a good point.
Yeah.
Cool thing about this is I can draw on my screen. One of those. So, let's see here. So, I'm just going to make it so I can have a little bit of a bigger area. So let me, oh yeah, good point. Oh wow, that didn't.
Didn't work.
Let me just test this, see what it looks like. That's like way too big. Maybe we're zoomed in too far, I don't know. Why not just go to a certain size? Huh. This kind of seems a little bit big and pixelated.
That's just because you enlarged the area.
So what do I need to do to make it
Bottom
normal?
right and zoom out.
Oh, don't be at 700%. Okay, so 100%, but then do I just need to like take this out?
Yeah, that should work.
Is that?
There you go.
Oh, there we go. Okay, good. I'll get a little bit bigger here. Okay, so if you have a dot, oops, so if that is the airport, so whatever angle, so if the report is coming from like this side, like if it looks like this and you've got your, you know, you've got your triangles on it, you know, like this. Not that that looks great, but probably looks just as good as the board would look. It's basically,
Don't worry about color.
it means that it's always pointing the direction. So that means it's going this direction. Okay? So if you see an airport and then you see it coming from this direction, and you know the triangles are down here, you know, and then it's basically going that direction. So whatever it's going, the angle that you see basically the airport circle will always, or not the airport circle, or the location of the PIREP in this case, will always be where the dot is, but the wind will always be basically pointing like through the dot, if that makes sense. So if you see it to the right, that means whichever side you see the information on, like if you see it all on this side, then it basically just means that it's going, you know, from that side, it's always going the opposite direction.
Like an arrow tail.
Exactly, yeah. It's like you're looking at the feathers, if that makes any good sense. So, anyway, yeah. Anyway, I'm not going to try and erase that. So, isn't there a thing where you can just like click and erase a whole area? Anyway, okay, I'll go back to it later. Let's see. So now we're going to look at, look at the text real quick of a few of these here. Let's see, so that's clear all, PIREPs, and let's see here. Let's look at it this way. Let's go. Let's see. We knew there was some like over, like Kentucky, out that way. Oh wait, that's not giving me the option for PIREPs. Okay. Well, we'll just go back to this. So let's go. Let's see. I know there's those ones over Wisconsin, so we'll look at stuff that's in Wisconsin. Okay, just PyReps and display. Okay. Can everybody see this? Is it showing up big enough?
Yeah.
Just hold the main page down just a little bit.
Let me see if I can just do it this way. Okay. Okay, that's showing up good? Okay, so this first one here, basically this one that we're looking at right here, this is how you'll see a PyRep from a text standpoint. So the first thing that's going to be listed is going to be the airport or the area that the PyRep is being issued from. Now in this case, MSN, Madison, Wisconsin, okay? That's basically where it was issued from. The next thing, you see it says UA. So a UA just means upper air, but it's just basically UA means PyRep, okay? Now, there's two things that when it says UA, that just means that it's a PyRep, but there's two different things you're going to see. A normal PyRep, and this is something you'll want to know, you want to write down. UA stands for a normal PyRep, okay? And if you see UUA, that stands for an urgent PyRep. That's going to be something that's obviously more significant.
That's UUA.
Yeah, if you see one that says UUA, that means it is an urgent. It stands for Urgent Upper Air Report, but you don't necessarily need to remember the upper air thing, but you just know that UA means PyRep. A UA means a normal PyRep. A UUA means an urgent PyRep. So if somebody encounters severe icing or severe turbulence, they're usually going to issue an urgent PyRep. So that's usually what it's reserved for, is something that falls into the category of severe. Now in this case, it's just a normal PyRep. It's from Madison, and then the next part there is where it's basically giving you their exact location, okay? So that OV means over, and then the next thing there means it's saying Madison, and it, again, Madison, but it's telling you that the exact location is Madison, but then it's telling you where it says 360, that basically means that if you're looking at a compass, okay, directly north is going to be 360. So they are from Madison, they are directly north, 360, and then that 020 there is how far. That's going to be nautical miles. So this is basically telling us that they are 20 miles directly north of Madison. So if you look at it backwards, that's kind of the way I like to do it, is they're 20 miles from Madison is what I'm kind of looking at here. Or they're in, you can look at it any way, whatever way is best for you. But the way that I kind of like it is to first know that they're in Madison or near Madison. And to be exactly precise, they're 20 miles away from Madison, going at a direction of 360. So 360 is straight north and at 20 miles. So that's exactly where it's happening. So basically when they report a PyRep, they're just basically taking, well, what's the nearest airport or what's the nearest navigational aid to where I'm at? And then they use that, and then they say, okay, well, if you take, okay, well, I'm 20 miles north of Madison, that's how it's going to be reported. They're going to put Madison, 360020. Now we'll look at more here, and you'll kind of get an idea here. And then the time is what the TM is for on the next one here, and that is 0008 Zulu time. Okay. Everything aircraft-wise is going to be Zulu. I know everyone has heard of Zulu. Jacob, you?
It's just like the international time, right?
Yeah, UTC, Universal Time. Yeah, exactly. Yeah, so that's Zulu. So the whole airline world operates in Zulu. Everything in weather reports is always in Zulu. So just get used to Zulu. Here in Utah, we are currently Zulu -7 or -6? 7. Okay, so we're currently Zulu -7. So anyway, that's the time, and then at flight level 130, so 13,000 feet. And then it's telling you the type. That means the type of aircraft. This is a Cessna 208. Now, don't be too concerned about your types of aircraft. You'll just learn those over time. But if it was a CRJ, you would say CRJ2, for a 200, CRJ7, CRJ9, or it would say E170 or E175. So that next one is your temperature, TA, and that M stands for minus, but it is minus 10 degrees Celsius. And then the next part there is, it's basically at the end here, it's telling you what type of PIREP this is, and that IC stands for that it is an icing PIREP. So it's icing, moderate, mixed ice. So if you go back to your types of ice, they're actually giving you the type of ice that they're getting. It's mixed ice. And it's moderate mixed ice between 130 and 140. So flight level, 13,000 feet to 14,000 feet. So does all that make sense? We're going to keep looking at them here. Let's look at another one. Okay, this next one down. Green Bay. Just a normal PIREP. And they are over BAE. Now BAE is a nav aid. It's called that's the Badger VOR. Same thing with nav aids and everything else. Those are things that you'll just learn later. I know a lot of you already know your city codes. GRB, that's easy to deduce for you too that aren't necessarily looking at city codes all day long. But GRB is Green Bay, Wisconsin, normal PIREP. Then the OV, once again, is over. And then BAE is the Badger VOR, which is VOR is a type of navigational aid that we're going to learn about next week when we get into navigation. But it's the Badger VOR, and they're telling us that they are 45 nautical miles northwest, so 320. Does everybody have a good grasp on their degrees of compass? Or I feel like they do. So 360, so I'm going 360. And then, so 360, 320 are going to be here. So 360 going this way, you're going to change over to where you're, 0 through, 90, 180, 270, just want to make sure. So 45 miles northwest of the Badger VOR. Now, we can look up where the Badger VOR is, but we don't really need to, obviously, right now. The time was at 005 or 0005 Zulu, flight level 330, 33,000 feet. The type of aircraft is an Airbus A340, so this is actually a fairly large 4-engine aircraft that we're dealing with here. And then it's just saying turbulence, so this is a turbulence PIREP, TB. Moderate chop is what they're reporting. So we'll go down to the next one here. This next one is once again, it's a Green Bay PIREP basically. It's not an urgent. This is just a normal one. They're over Green Bay. So if it just says over Green Bay, that means directly over Green Bay. So it doesn't have any direction in it. That means they're straight over Green Bay. The time was 23:56 Zulu. Flight level 300, 30,000 feet. The type on this case is a Boeing 767-300. So same thing, big wide body aircraft, and then it's a turbulence PIREP. It's a moderate, and then the CAT stands for clear air turbulence. So then that next one down is the one that we already looked at again. But we'll look at these more. But
do pilots submit these when they're solicited from them, or do they do it just they feel the need to, or both?
Both. So ATC will solicit a lot of PIREPs. Dispatchers will solicit a lot of PIREPs, and then pilots themselves, if they're not being solicited, if they have something happen that they want to report, then they'll just get on there and say, hey, I want to issue a PIREP. So it's a mixture of all three of those things. But as a dispatcher, you can actually enter PIREPs. So a lot of times, and you guys have maybe seen them, those of you that sometimes see the ACARS messages, and if you remember I was telling you about ACARS messaging, it's like the text messaging in the airplane. A lot of times you'll be, as a dispatcher, you'll suddenly get a message that just says, you know, moderate chop 320. You know, that's all it'll say. And dispatcher's like, great, thanks. So it's basically just him giving the dispatcher, in a way it's a PIREP, but, you know, kind of shortened version. But if you as a dispatcher, you know, if you're bored and got nothing else going on, you can take that report that he just gave you, and you could actually jump in and you could enter a PIREP so that it shows up just like these ones do for the rest of the world to see. But dispatchers can enter them, ATC can enter them. Those are the only two people that can actually enter PIREPs. And then obviously pilots give them, you know, they don't enter them, they just give them. But you can jump in there and you can enter it in, and if a pilot just sends you that report, then most of the other information you can just get yourself. Because if he just sends moderate chop 320, that's really all you need as a dispatcher, because if you're the dispatcher and you just got that, well, you also have the timestamp that he just sent it, so you got the time, you know what type of aircraft he's flying, you can see where he's at on the map, and you can enter in the rest of it because you have the rest of that information. So, so yeah, you can do that as a dispatcher. Some days, you know, like when I'm bored, I'll jump in there and I'll enter PIREPs if I'm getting them. So they make it kind of easy for us on Fusion. Those of you that know what Fusion is and have seen it, you can actually just on the screen, wherever your plane is, if you just hover over your plane, you can right-click, and there's a little drop-down box, and you can go to the thing that just says, there's a little option that just says Add PIREP. You can click on that box, and it actually brings up all of that little information. You just fill it in, hit enter, and it sends the PIREP out into the ATC world. So works out pretty nice.
So does it fill in all the information, like the location?
Yep. Yeah, when you right-click, it
knows where the aircraft
it knows where that plane is, so it fills in all of it. It gets the timestamp. It gets all of that. All you really fill in is what's occurring. You know, what the turbulence is, or if it's icing, or if it's wind shear, or whatever the thing is that they're reporting. You fill that in. Everything else it has, and then it knows the altitude. It knows everything. So it actually works out really smooth for our purposes. You can also go directly to the ATC website and enter them in, and I can show you later on here, but yeah, I think that is all we need to cover there. Area forecast, center weather advisories. Those last two things, area forecast and center weather advisories, are really just I'll give you an example of what they are, but let's take a break first. Let's just take 10 or 15 minutes, whatever you need, and we'll come back to that. Okay, so now we're going to jump in, and so just these last two little things here. The area forecast and center weather advisories are, an area forecast is kind of like a TAF. The only difference is that it's basically including a large region. I'm going to hurry and show you what one of those looks like. And generally speaking, though, that it's not something that we look at and use too much. You can kind of see here, so this little box I'm clicking on, area forecast, so you can see that these are the only ones that are available, just these areas. So if I click on Salt Lake City as an example, display, so let's see here, I'm going to get rid of all of these first. All right, so this here is an area forecast, and I just pulled up Salt Lake City. So as you can see here, there's only 1, 2, 3, 4, 5, 6, 7, 8. So there's only 10 of them nationwide. So it kind of gives you an idea of how big the area is. 10 of them cover, well, including Hawaii and Alaska. Well, so really 8 of them cover the lower 48, and then 1 for Hawaii, 1 for Alaska. So anyway, so over here, I'll bring it up so we can see it a little bit better. Okay. So this is basically just, so it's an area forecast. It's for Salt Lake City, and you can see the other ones that were in there, but this basically just kind of goes through the areas that are within the Salt Lake City region, and it gives you an overall look of what the weather looks like in that entire area. Now, a lot of these are mostly just all acronyms, and so you'll slowly become more and more familiar and comfortable with all these acronyms, but just to kind of look at what this is telling us. So the first one here, well, we can kind of start from the top here. So this is the Salt Lake City Center, area forecast. It was issued on the 4th of May at 1945 Zulu. The synopsis and VFR clouds and weather synopsis is valid until 14 Zulu on May 5th. Clouds and weather are valid until 8 Zulu on May 5th. And so basically it's just telling you the validity and when this report expires. And it's good for the areas of Idaho, Montana, Wyoming, Nevada, Utah, Colorado, Arizona, and New Mexico. So that is the area that this area forecast covers, okay? The first thing it tells you is if there are any airmets or sigmets in that entire region, and for us there's just the one airmet that exists in that entire region. It says see airmet Sierra for IFR conditions and mountain obscuration, thunderstorms. Actually, let's see here. So actually, you know what, going back, this doesn't mean there's an airmet in the area. It's telling us that we need to go and individually look at the airmets to see if there are any. So, but we already kind of looked at the airmets earlier. There's not anything. Let's see here. Let's see here. Just trying to, I gotta remember some of these acronyms myself. So we don't look at area forecasts very much. So I just wanted to show you this, but generally speaking, we really don't look at these. So don't judge me too bad because a lot of these things I don't know. So not sure I know what the ALF means, but it's, okay, aloft, there you go. Okay, yeah. Synopsis, okay, so this is the synopsis for the whole area. So aloft, yeah, high pressure ridge throughout the Rockies will continue. Yeah, the mountain region through the outlook. The eastern portion, upper level trough will approach the northern Sierras, 12 to 14 Zulu, anticyclonic flow through Utah, surface high pressure, or maybe that's throughout, or is that, I don't think it's through Utah, throughout. So anticyclonic, does everybody remember what that would mean? High pressure. Cyclonic is counterclockwise, anticyclonic is clockwise. So anticyclonic means that there's a high pressure. So then specifically Idaho. Northern portion of Idaho, skies clear, occasional scattered, I think that's clouds, or scattered, yeah, I don't know what the CI is. I'll have to look that up. So then that means becoming. Then at so let's see, 04. So it's at 6 Zulu. So fourth. So that when it says 0406, it's the first part's the 2-letter or the 2-digit date and 2-digit time. So it's 4th of May at 06 Zulu. Is scattered again. I'm pretty sure it's just the clouds. Obviously, I know scattered clouds, but the outlook overall is VFR. And then the central portion of Idaho, mountains, skies clear, outlook VFR. Southwestern, skies clear, outlook VFR. And southeastern, skies clear, outlook VFR. Okay, so Montana, that first one means the Continental Divide. So the Continental Divide on the western is skies clear, becoming at 0306. Trying to, maybe it would help if I brought up a thing. Just goes to show you how little we use these, but generally speaking, you're not going to really look at an area forecast too much because you're going to want a little bit better information. So you're not going to look at a whole thing for the whole state of Montana, considering that we dispatched to 8 different airports in Montana. It's not going to really help you. I mean, it'll help you, if the whole thing says outlook VFR, for eastern, central, the eastern slopes, the southwestern mountains, the Continental Divide area, if it all is saying the same, then yeah, that's going to give you a good idea that all of Montana is good weather. But, generally speaking, it's not going to be something you're really going to look at. Wyoming, mountains and west, skies clear, outlook VFR, the eastern plains and foothills scattered 10,000 to 12,000 feet. Skies clear, outlook VFR. So you can kind of get the idea. I mean, most of this is pretty good. I'll bring up one for the west, or sorry, the east, where it was kind of bad weather. Just real quick, just as an example. Let's take a look at, let's take a look at Chicago. I'm just going to leave it on this smaller scale one, just to see if we can make a lot of sense of it. Let's see, I did one here. Is this showing up very big?
Sorry.
Visible? Okay. So let's say Missouri, the northwest part of Missouri, skies cleared, scattered, outlook VFR, northeastern to southwest, scattered to broken 7,000, tops at 12,000 feet. That just means the top of the clouds. Kind of makes sense of what the becoming 04, because clearly that isn't the time. I thought it was the time originally, but so scattered till 9Z, occasional, scattered 6,000, outlook VFR, northeastern, I don't know what the WND is. The what? Wind? I guess, yeah. Works for me. I'm assuming that's extreme southeast. Overcast 1,000 to 2,000, tops at 24,000. Visibility 3 to 5 statute miles, scattered. That next one is light rain showers and mist is what that is meaning there. Did everybody, when they were going through the METAR stuff, go through all of those individual little things? You're gonna, same thing, you'll become very familiar with all of those little acronyms in those. So that right there is light. So it's kind of worded backwards, but the minus means light, and then SH means showers, and then RA means rain. So, but you say it, obviously, light rain showers. And then slash BR stands for mist. 10Z, scattered 4,000, scattered 12,000, scattered to broken. Outlook, VFR. See, the WND just doesn't make sense there for wind, though. I don't know. VFR wind? VFR Wednesday? I don't know. The remainder of the southeast, overcast 7,000. Tops at flight level 250. Isolated rain showers. So anyway, you kind of get the idea. These are area forecasts. Like I say, they're not really all that great and helpful. We don't really use them. But that's what it is. The last thing, center weather advisories. So when it talks about these, obviously the whole United States is divided up into ATC centers. And within each of those centers, the ATC can issue a weather advisory. And basically, all it is that if, like going back to that example of icing segments and turbulence segments, most of those come about through pilots reporting to ATC that is actually going on. And when that happens, in addition to entering or issuing a SIGMET for whatever weather, they'll also issue a weather advisory for that center. So if it's over Colorado, then it would be mostly Denver Center is the ATC center, but they would issue a weather advisory. And basically what happens is it's kind of like a broadcast that goes out to all aircraft that are in that center, and it just, they're in the airplane, it comes over a certain frequency, but all aircraft in that center should be monitoring that frequency at all times. So they have several radios, and one of those radios in the airplane is monitoring that center weather frequency. And if there's something like that happens, because if you think about like airplanes up in the air, like if a SIGMET is issued, it might not be necessarily instantaneous that a dispatcher is going to see that and then be able to tell the crew, okay? Sometimes that could take 20, 30 minutes, and some dispatchers never. So, so they have this frequency that you're always supposed to be monitoring in that given area, and if there is significant weather, then they will broadcast it on that frequency so that the pilots and the planes in that area can immediately get that information. So icing SIGMET, whatever, just issued for this portion, and it'll tell them the points. Like all of those boxes are like specific points. So like 30 miles from Rock Springs to 20 miles north of Laramie down to 20 miles southeast of Pueblo. It'll define the box in that center weather advisory, and that's basically what that is. It's just them broadcasting to all the planes in that area of what's going on, and telling them about the significant weather. So We normally don't obviously hear those because we're not listening to ATC. You could see them once they're published, but it's also not something we're normally out looking for. If we see a segment pop up, that's what we're looking for. That's the first thing we're going to see. And we really don't need to see the center weather advisory because, like I said, it's really for the people in the plains instantaneously getting the information instead of having to wait for other dispatchers or anybody else to give it to them. So our notification is really just seeing the segment pop up like on your map. So that's really it for center weather advisories. As far as the rest of today's stuff, these are all just charts and stuff. And so we're going to start looking at these charts, and we'll be able to go through these pretty quick. We'll be able to get through really most of this even in just this last hour. And the other thing is that we're just going to briefly look at these, but just know that later on when we're doing flight planning and stuff, we'll be looking at these charts pretty much every time we do a flight plan. So you're going to see all of this plenty. You're going to get a lot of familiarity with this later on because we're going to look at this a lot when we're planning flights. So don't, worry too much about what parts of it you get and don't get right now. So that first one was surface analysis. So we come back into our aviation charts. Okay, so this is, let's see if I can, so that's showing up okay size, right? Mm-hmm. Okay. So this is a surface analysis chart. It's really just kind of giving you an idea of what, and in this case, the entire United States, continental United States, of what the weather is in all areas of the United States. And this is all based on weather on the surface. Okay? When you look at, there's several things to just look at on this. Obviously, it's giving us all of our high and low pressure centers throughout the United States. We can see a low northwest up here, a high over here, kind of over Jackson Hole, a high down here, northern Arizona, southern Utah. Then you've got a low, seems like kind of down over the California-Arizona border. You can all kind of see where all of these are at. You can quickly look at this and see, obviously, that weather, out here and mostly the western United States and most of the Midwest is fairly good just by looking at this. It shows you the satellite overlay. It also shows so it's kind of a mixture of several charts. It's a mixture of high and low pressure centers. It's a mixture of radar, satellite, and frontal, showing you the frontal systems. You can see, these blue triangular lines up here are all, this is a cold front. You can see over here you've got the blue, or sorry, not the blue, but the red. This is, kind of a warm front mixed in. So this one that looks where you've got the triangles, where you've got both like the triangles and the circles, the red where it's both like back and forth. You can kind of see this entire line goes red, blue, red, blue, red, blue. So cold, warm, cold, warm, cold, warm. So does anybody know what that's called from when you looked at fronts? Occluded, yeah, occluded. So that is an occluded front, basically where it is a cold and a warm front kind of moving along together where they're just kind of moving along the same line. So, the other ones are pretty easy to, all blue, cold front, all red, warm front. And then you have you know, like this one here, like where you have your troughs. So that would be a trough there. I'm trying to see if we have a ridge anywhere.
You know, like trough in Florida.
Yeah, trough over here in Florida. And if you remember when we looked at the convective segments? Remember that convective segment that was basically right in that same spot? That's so you can kind of associate like a trough a lot of times with a line of thunderstorms as well. But yeah, ultimately this chart is basically just a quick look at the, you know, anywhere. You can also click and zoom in if we want to, you know, zoom in over here. You can zoom in. It does give us our lines of pressure, but these pressure readings are, remember, this is all based on surface readings, and this is going to be your these are what do you call it? Obviously, it's not your inches of mercury, but it's I don't know why the name is escaping me right now. Yeah, your millibars. Sorry. But yeah, those are your millibar readings, but these are all based on the surface. So when you're, you know, like on our, you know, when as dispatchers at work and things like that, when you have your, you know, everybody can set up their stuff differently on what they want to see on the weather, like on their fusion systems and things like that. But most people will have like a surface analysis. They may not have like the actual satellite image up. Let's see. Like where it's showing like the gray, because the satellite imagery doesn't really help us a ton. The only time it really helps us is if we want to know if there's, you know, cloud cover or a ceiling or something in a certain area. But generally speaking, nobody usually is looking at the satellite. We're really looking at the radar, like, you know, where you see the green and the yellow and red and stuff, where it's actually giving us, you know, radar feedback of the, you know, what the precipitation of a certain area. And well, obviously we'll get more in depth with radar stuff, but this is a surface analysis chart. It's a whole host of things that it's showing us. Fronts, highs, lows, pressures, radar, satellite, and pressure readings. So let's go take a look at the next one, which is a weather depiction chart. Weather depiction right here. Okay, so a weather depiction chart basically is giving us more of a textual reading of the weather. Instead of showing it, it's not showing us, obviously it doesn't show us any satellite or radar. What it basically is doing is it is drawing lines, and so where you see that it shows, well, you can actually see down here, so you see this little legend here where the blue stands for marginal VFR and the red is actual IFR areas. So anywhere that it's not blue or red means that it's VFR weather. But over here, where you have the blue and the red, if you remember kind of those differences between VFR, marginal VFR, and IFR, that means the marginal VFR is going to mean that anywhere that's blue is going to have ceilings of between 1,000 and 3,000 feet and visibility between 1 and 3 miles. And anywhere that's red is going to be IFR, which is basically just ceilings of 1,000 feet or less and visibility of 1 mile or less. So it does show our frontal systems on there. All these little text things here where that says CIGS just means ceilings. There's actually another little legend here that I want to, where is the, let me see if I can get into it real quick. I'll just bring up the little thing that has the, okay, there we go. Everybody see that good? Okay. So you can kind of see, this is telling us what this all means. So you see, so most of the stuff we were seeing was that CIGS slash and then the 2 dots. That means rain. Now you don't need to memorize these. This is obviously not something we're really ever looking at specifically. You can see this one we did in the northwest. You kind of saw some of these ones that had the ceilings with this like R-shaped design here. That means thunderstorms. But you can see all the different types that you have here. Over here you've got like the $, which means blowing dust. The CIGS means, you know, ceilings, obviously. The 3 lines means, you know, dense fog, just moderate fog. The little snowflakes here, heavy snow, moderate snow, light snow. These up here you can see hurricane, typhoon. A tropical storm would be with the little dot in the middle. Tropical depression. And actually, you know what? So this gives you your fronts thing. So I had my occluded front wrong actually. So yeah, the one we were looking at was stationary. Occluded is pink. Let's see, weather depiction. So I'm going to look at something else here. Okay. Surface analysis. Okay. So anyway, so that kind of gives you an idea for basically, it's just telling us, you know, if you're looking at this map, it's just giving you a quick idea of what a specific region of the United States, what kind of weather they're having, with more or less a text format, you know, a mix of the text obviously, and then the color shading. So generally speaking, it's not something you really use very much. Significant weather prognosis. I'm going to keep this up so we can go back and forth to it. Okay. So the significant weather prognosis chart. So this one does have different levels. So this one here is a North American high level significant weather. So a prognosis chart is just telling us, once again, kind of in a text format, you know, what's going on in a certain area. So it has most of the legend on this is down here at the bottom. These little things are going to be your jet stream, like the height and the speed of the jet stream. So like right here over Washington, the jet stream is going directly north if you follow this blue line, straight up into Canada, up into the Arctic at 100 knots, flight level 340. You've got another jet stream, you know, over here coming down from Alaska, you know, in towards Northern California, 100 knots, flight level 300. You have these areas like this dotted line that's shaded around over here. So this entire area that's got the dotted line around it is basically an area of turbulence, is what it's trying to say. Right here, this little, let's see if we can maybe zoom in a little bit. Is that any better? So over here you've got, these are basically just all telling us like what type, of turbulence. If you kind of see here, you've got moderate to severe, and then severe. So this is kind of just telling us this area here has got the 2. So this is telling us that there is some severe turbulence kind of right up in this area. But throughout the kind of the shading here, you can expect turbulence anywhere in this area. Let's see. So the shading over here. So this, if you see this, it says CB areas. So CB stands for, it's denoting cumulonimbus clouds. So that's what CB stands for. So this is basically telling us an area of potential cumulonimbus clouds or thunderstorms is what it's really trying to say. So you can see here there's green, that would mean kind of just isolated. So this area would have isolated, this area here, this area along the eastern coast of the United States is saying occasional. I don't see anywhere that has frequent. I don't know why you would think that they would have that line of thunderstorms along the Florida coast. Maybe it's showing up in there, but it doesn't have anything. Let's see, that's the jet stream. So the other things in here, the tropopause, it's basically telling us, so if you see these like 550, that's 55,000 feet, 45,000 feet, 39, that's telling us the height of the tropopause in that area. So when you're talking about like the tropopause, that's a lot of the airflow in the United States likes to occur basically, right at the level of where, where the tropopause, like it is meeting our normal atmosphere coming down. So if you look at like the jet streams, a lot of times that air in the jet stream is usually, it'll kind of flow with like the different levels of the tropopause as it comes like down. Like you kind of see like some of these areas where it's a lot lower. So it just will fluctuate depending on the high pressure and low pressure systems. This is not something that you necessarily need to get way in depth on. It's not something that really anybody knows much about. I mean, I hardly know anything about it myself. So it's not something that really even relates to us because we never fly into the tropopause. So it's not really something that matters too much. These are more, for meteorologist type things to help them do forecasting of, wind and jet stream flows. But volcanoes, you can see over here, like there's, a volcano down here, like in Guatemala. This is only showing us volcanoes that have active stuff going on with it. So like there's a lot more volcanoes like through here in like central Mexico that often are active, but if it's active, it'll show up like this. Radiation, I don't see anything that's saying that. And tropical storms and hurricanes, don't see any, but you obviously know where you'd normally see them, in these areas over here. But so that's a significant or a high level significant weather chart. Winds and temperatures aloft. It's going to be down here. So we've got our observer. So this is going to be a mix between two different charts for us here. Let's see where to go. So observed winds. So this is going to be our winds aloft here, and we can actually change this. So if we want to look, so this has the flight level up here. So this is 14,000 feet. This will kind of give you a better example. And by the way, when I was telling you about the wind speeds on these, I was off on the, so the triangle, in fact, I just want to make sure because a lot of these, like if it's depending on if it's like WSI, they're supposed to be like standardized, but some of them will change. So these like this one here, like the triangle is actually, I believe, 10 knots. So I'm going to jump in here and just make sure that I'm not telling you guys something that's just crazy. Okay. Let's see, this is kind of weird because this one, see, and earlier I was saying 25 because, see, it doesn't, well, I guess it doesn't really make a lot of sense because this one here, so 50, 10, 5, so that's 65. So the ones that we were looking at earlier on that other chart where it was like 4 triangles, so that would have meant that it was 200, but you normally don't ever. The reason why I was thinking 25 is because 200 is not something you normally ever hardly see. So anyway, maybe it's just crazy extra windy. So anyway, so yeah, triangles are 50. We'll just go off of obviously what this is saying. So 50, the long barb is 10, and then the short barb is 5, and then it points the direction. The only thing I probably did tell you correctly is that it points the direction that it's actually blowing. So, whoops. This is at 14,000 feet. The wind blows higher, or at a higher speed, obviously, as you increase with altitude. But this is giving you the temperature and the wind speed. And so this wind here is blowing straight north. And if you remember when we saw that jet stream, when we were looking at that jet stream a few minutes ago, how it was blowing straight north over here over Oregon and Washington up into Canada. Well, you kind of look at the wind here, and as we increase this is at 14,000 feet, but you can see even at 14,000 feet the wind is blowing straight north. As we get closer to the surface, you'll notice when we were talking about that Coriolis effect, that the, like mountains and things like that will actually, they make the wind obviously die down to where it can't flow in a generalized direction. But as you get closer to the ground, you'll notice that the wind will take shape and conform more to what you call the local wind of, a given area where it'll, flows, different directions and obviously at way lower speeds. But as you increase in altitude, you get the more generalized direction where they follow the jet streams and increase in speed, and obviously gets colder. So at 14,000 feet here over Oregon, you've got 10, 20, 35 knot winds blowing straight north, and it's -5 degrees. You can kind of see, over here, over Montana, the wind is blowing southeast at 30 knots. And it's -4 degrees Celsius at 14,000 feet. So let's bump this up. Let's go to flight level 240. Should see everything increase. So let's go back to that same one over Oregon. It's 10, 20, 30, 45. So 45 knots blowing straight north, and now at 24,000 feet, it is -26 degrees Celsius. And see some of these other ones over here. So 50, 60, 70, 80, 90 knots blowing directly south, -33 degrees. There, and this would be like International Falls, it looks like, Minnesota. Minneapolis is 60 knots at 24,000 feet, -33 degrees. But you can kind of see the shapes. You can see the wind is blowing north here, and then it turns and is blowing southwest here. It's almost directly south over here. So you can see kind of where the jet stream is just without even knowing where it's at, because you can follow the wind. And then it comes back south, and then it turns back north right here. So let's jump up to 34,000. So going back to the same one over Oregon here, again, 60 and 60 knots straight north, -52. Some of these other ones here. So there's 105 knots and straight south, -53 degrees. See if we can find some faster ones. So 50, or sorry, so 110, so 115 blowing straight east, negative 50 over here over New Hampshire and Vermont. It kind of gives you an idea. You can kind of see as you get a little bit higher that wind shift actually starts a little bit lower instead of going clear up north. You can see it shifting at a lower, further south here.
125 on that main notice section.
Over here? Yeah. Is that the highest one we have? Looks like it. Anyway, so that's your wind and temperatures aloft. Our tropopause chart, we already kind of were looking at that. Let's see if they actually have a specific one for that though. I don't believe they do. Oh, I don't believe there's one specifically for it other than the one we already were looking at that showed you the tropopause heights, but either way, it's not something that we normally get too concerned with. This one, let me just look at this one real quick. This is going back to your jet stream. So this is showing us the jet stream flow at 30,000 feet. So you can see that, so this little thing here is giving you an idea of the speed. So the yellow areas is 70, then 90, 110. Once it gets blue, I don't see any real blue areas, except maybe like right over in here. And then obviously the really pink is, higher speeds, but you can kind of see just kind of the idea of the flow of the jet stream. When you see the jet stream like as just a single little line that it draws, like on some of our stuff, that like that other one, that first one that we looked at where it was going straight north over Oregon and Montana, it's kind of not really doing the jet stream much justice by looking at it like that, because it doesn't really give you an idea of like how wide it really is and where it's really starting to like turn at. But you can see in these areas, going back to when we were talking about high and low pressures, this map does a really good job of showing you those high pressure and low pressure centers, because if you look at the flow of the air here, you can see that it's coming up and circling over. You kind of see this if you look at it, obviously, but this right here is a high pressure. You can tell it's going in a clockwise direction, and then right over here the air flows down and around, so you can see this is going counterclockwise, so you got a low pressure sitting right over here. So this is a good chart that actually really shows that wind pattern and the circular cyclonic and anticyclonic motions of the wind. Composite moisture stability chart. And the surface weather prognostic chart, and then the radar and satellite. Okay. So there's one here called the precipitable weather. There it is. So this is your precipitable weather analysis, which is what that other one was referring to, but it is really just giving you kind of an overall idea of how much moisture any given, or the air actually has in it. So if you kind of look, you can kind of tell more or less like how much moisture is in the air in any of these given areas. So, and this helps, with relating if you're looking at this, and really the only reason you ever would be looking at this is to understand if you want to know how much moisture is in the air in a given area, then you would look at this chart. And the only reason that looking at this really helps you is it gives you an idea what the potential is in any given region for clouds to be forming, ceilings to be forming, for thunderstorms to be forming. Obviously, the more moisture you have in the air, and as you've kind of seen back through the last few days where you've been learning about the certain elements that it takes to create weather, where moisture, heat, the air obviously being heated up, and if you have an element of moisture in the air as the air is rising up, that's where you get your clouds forming, and that's obviously where you're going to get your thunderstorm probabilities and things like that that'll form, because the more moisture there is in the air, the more probable it is for adverse weather to form. So clouds in general, obviously, are formed with moisture, but the more moisture there is, the more energy the air will create. So as you get that heating process where the air is being lifted up and you have that moisture that's in the air, as it heats up, that moisture and those molecules of air, or so the molecules, the water vapor in the air, start colliding and creating that heat and that energy, and that's really what ultimately forms thunderstorms. And so when you're looking for thunderstorm probability, this chart will help you, because when you look, and if you look back at the chart that showed us where thunderstorms were occurring right now, you look at this and you see, obviously it's going to be in more humid areas are going to be always the worst, but you see 1.3, 1.37, these higher levels of moisture, is where you see all your bad weather, and it's where you see all your area that has ceilings, cloud ceilings, and fog and everything else in them. And then same thing up here in the Pacific Northwest. Other than that, I mean, this chart really isn't something that we look at much as well. So that next one, the surface weather prognostic chart. So you've got a significant weather prognosis, and then you got a surface weather prognostic chart. What's the prognosis? That's the prognostic. Okay, so if you kind of remember that first chart we looked at, the surface analysis chart, the very first one, it kind of looks similar to that chart. The only difference is that this chart is a forecast. This is telling us basically all of those same things that first one showed us. The only difference is that this is what it is expected to look like 12 hours from right now. So you can go and you can change this. So that's 12 hours, and then 24 hours from right now, this is what we expect it to look like. So these high pressures move more over the Midwest. That low system over the eastern part of the United States starts moving. You can kind of see that. I mean, this is 24 hours from now. This storm over here is really not all that fast moving, because it really, if you look at how it is right now, it's really maybe like right here, and 24 hours from now it's only going to be right here. There's really not too much movement. Anyway, you can just change this and keep going down. So the further you out, so 36 hours from now, this is what we can expect. That has moved a little bit more northeast, but in general, you still have this area of adverse weather, rain, low ceilings. Now that system that's currently over the Pacific Northwest looks like it is going to be moving down, inching, ever so close into Utah, Nevada, and kind of getting closer to us here. So we can see that we've got a cold front that's moving towards us. And this is 36 hours from now. Yeah. Yeah, so a lot of times, the funny thing is the only time I really ever use this, I mean, as a dispatcher, you don't really care what it is 36 hours from now unless you're worried about how your day is going to be. If you're working 2 days from now, that would be the only thing you would care about is, oh crap, is Thursday or is Friday going to be crappy, or Saturday. There's no real other reason to look at this other than that. The only time I personally ever look at this chart is when I'm traveling. So, it's basically, I just look at it and mostly it's when I'm driving. That's the funny thing. I don't really look at it when I'm flying because I don't care too much unless you're worried about flying somewhere and worried about, one of those situations where you fly somewhere and then that area gets hit with a bad storm or something like that, which causes flights to cancel. I mean, that would be one reason to care. But for me, I always look at this. If I know that I'm going to drive up to Salt Lake in a couple of days, I like to know what it's looking like, if I want to plan on driving, and that's, ironically, that's more what I use it for personally. But let's see, let's look at 48 hours. So 48 hours, it looks like this front kind of stalls out. So as you can kind of see, like when we looked at this before, like at 36 hours, this still all was a cold front moving. Now they're saying at 48 hours, it looks like it turns into a stationary front. So this high pressure over here, basically what's happening, in this situation is that low pressure that's moving in from the northwest, and then this high pressure, which is currently like right now, that high pressure is like right here, and 48 hours from now, it's only going to be right here. But it's this system moving in is just not powerful enough to really push out this high pressure. When you have a really strong low pressure system, that's when it moves through faster, and it'll kick that high pressure right on out of here normally, pretty fast if it's strong. But this clearly is a very weak storm, and it's so weak to the point where it's going to turn, they're forecasting it that this is going to turn into a stationary front. And then when you get stationary fronts, I mean, that's when you really start to see like these troughs developing, and this high pressure will probably end up just sitting over here, and this low pressure will end up just sitting over here. But when you get that type of weather, when how sometimes weather can like just sit over a certain area for just days and days at a time, that's kind of an example of a stationary front or a trough in some cases. But that's what's going on, is where you just get a storm it's a low pressure, but it's not strong enough to really move out, and it's not strong enough where it's so weak that the high pressure that it's up against is keeping it in place. So let's see what they show 72 hours out. So at 72 hours, they do finally kind of show it. You kind of notice how it changes graphics. Once you get so far out, it's so much of just kind of a crapshoot that they kind of just start drawing it all different and stuff. High pressure still over here. Low pressure looks like it does move over, but at this point, now they're showing the occluded front here. It looks, like it's still fairly weak. As far as St. George goes, it looks like we miss. According to them, it looks like we're going to miss most of whatever that's supposed to end up doing, but I don't know if 96 is going to... So 96 hours out, it looks like there's finally actually some precipitable weather here. So anyway, that's what this is. So when we're looking at radar meteorology and satellite meteorology, the radar meteorology is really the big one for us. I'm going to actually go over to radar. When we're looking at radar, we have the radar that we're seeing is always going to be a little bit delayed. The best that we can get is 5-minute radar, which is this far right chart over here. So I'm going to start though by looking at the 15-minute radar. So this is 15 minutes old, and it updates every 15 minutes. That's where I clicked on it. So this is the ones that we're really more concerned about as dispatchers. If we have a plane that's currently in the air flying through this area, we want to be able to zoom in, and this is kind of nicer on these ones because when you zoom in, it actually zooms in. It doesn't just make the pixels bigger. If we've got like last night when I was talking about Paducah right here. So, I had my plane coming down, and then I was seeing stuff like this. I can even zoom in a little bit more here. But I was seeing, a storm here like to the south, and then I was seeing one kind of similar to this, but it was up here, and Paducah was kind of what you see now. It was, other than there was, some yellow up here, but Paducah was right in the middle and looked just fine, and then 5 minutes later, then Paducah was right underneath what this looks like right here. But that's obviously what we're more concerned about, as dispatchers, is looking at the real-time radar. When you're looking at this, green is just light rain. Yellow is going to be just medium intensity. And the ones that you really care more about, is going to be your orange, your red. That's your really heavy intensity. You kind of can see the chart up here. Light, moderate, heavy, very heavy, intense, extreme. So, but all of this that you see here is really nothing more than, there is some heavy, so I guess the yellow can be heavy, but it's really just heavy rain. So a lot of people will get, especially pilots, a lot of times they'll pull up the weather on their phone. Just to kind of give you an idea, I'm going to see if I can pull up something that you might see. What's one of the sites, like Radar Now or something? Let's see, the one that they like to pull up on their phones.
My Radar.
Yeah, My Radar.
Got it on mine.
Okay. Yeah, My Radar. I'll try that if there's just myradar.com. Okay. Is there not like a... Let me actually, you know what? I think I can actually look at it in WSI here. Let me go to... Let me look at the satellite here for a second. Okay. This is better. So like those websites, oh, there was no zoom area there. Okay. Oh, whatever. Let's click map to zoom in. Anyway, as you can see this, just by looking at this, what looks worse? This or the one we were just looking at? Just from a visually perspective. You think the other one looks worse? So go back to this one. I swear this thing does not click when I click on it.
You mean like worse weather or worse detail?
Oh, okay. So like if you were a pilot, or anybody for that matter, if I show you, if you knew you were going to fly through the eastern United States, let's say you were going to fly all the way through it from like, from here and go all the way through it, and you're going to like New York. If I showed you this chart as compared to, and just kind of remember what that looks like right there. If I show you that as compared to this, which one scares you more?
Probably that one.
I would say this one
Yeah.
shows, I would think there's more weather associated with this one.
Yeah, exactly. This one's a lot more colorful, right? I mean, this one has like the kind of the yellow green all through this area and these blues, you know. So this has it like, it makes it look like this entire area, to me, it makes it look like this whole area right here is bad. But when I look at it over here, I mean, I do see some, you know, spots of yellow, but that whole area that was right here is all green. When you zoom into it, I mean, that's kind of a zoom in, but, you know, that was all right in here. That's what it really is. I mean, but when they look at those apps on their phone, they call us and they like freak out like, oh, that just looks horrible out there. I'm not going, you know? And a lot of times when they're talking to you on the phone, they don't even believe you. Like, well, I'm not showing that, you know. I'm showing everything in West Virginia. I'm showing parts of West Virginia that doesn't even have rain. I mean, if you look at this, you know, like this little patch here, no rain, but everything in West Virginia is light. This whole thing is light rain. It just goes to show you the difference between the accuracy of satellite and like the infrared satellite stuff as compared to actual radar on the ground technology. Most of these, see every one of these little city codes that you see on here, those are actually radar stations. So this map is taking all of those radar feeds and putting it together as a map. Whereas the other one is a big satellite up in the sky just shooting down. It can't see through it. It can't see depth. I mean, some satellites are better than others, but this is still the best satellite that we have. Now let's look at West Virginia on this one. The whole freaking state is yellow-green. So anyway, you can see the difference. Most of those apps are showing you this. And some are better than others, but there are some pilots, when they get on there, this is what they see, and they just think it's really bad, but they don't have access to see, you know, what we're really looking at. So anyway, just to kind of give you an idea, the radar is the one that we really care about the most. Like I was saying earlier, the only time we ever really look at the satellite stuff is like, you know, if I want to know if like San Francisco is going to have like cloud covers, maybe some ceilings, you know, you can, like, I can look out here and I can see these clouds maybe moving into San Francisco. And that'll give me an idea of whether San Francisco might have flow later on, like, you know, air traffic flow. Because I can see, you know, you might be able to see a layer of clouds out here over the ocean that might move in over the Bay Area. That's about the extent of what I would be using that for, as far as, you know, any helpful terms for a dispatcher. But the bulk of what you're going to always use is radar. So that was the 15-minute one that we were looking at. This next one is the radar summary. And this one actually is showing us actual cloud tops, you know, the height of the clouds here. So you can see like this stuff over here over Tennessee is at, so the tops of the clouds are at 35,000 feet, and it tells you the direction they're moving. This arrow is pointing south, and that's 8 knots. So that little storm system that was over Florida, you can zoom into it a little bit better. You can kind of see 40,000 feet, 45,000 feet, so the really high clouds, and then it's all moving northeast, 45 knots, 31 knots, 33 knots. You can kind of see all that movement in there. This red box here, I believe this is a thunderstorm watch area. I have to go back and look at the other thing, but I can go back and look at the convective segments too. But anyway, so this is the, you know, this is this is more of what you're using. If a pilot wants information, like, he's about to fly over here over this Knoxville, Tennessee area, and he's going to be in this area, he might solicit you for information like, hey, what's that storm cell looking like ahead of me, and you're going to say, well, its tops are 35,000 feet and it's slowly moving south at 8 knots, and you can zoom into it, and kind of give a little bit of a better idea once you kind of look into that area. Kind of, give him an idea on like maybe a route that he might want to fly instead. You kind of see throughout here, it's like you look at this and like stuff is moving all different directions. You can kind of see just by looking at this that the cyclonic motion here. You can kind of see this air moving up, this start pointing around, and then you get over here and it's moving this way. You can see it like on so many of these charts. You can actually see this motion.
On the ones that don't have arrows, are they basically just going in the direction of a nearby arrow or something?
Yeah, generally speaking, or they're just slow enough that they're just kind of stationary. Okay. But generally, when you really zoom in like this, like if you're looking at like this one here as an example, it doesn't have an arrow. But if you look at everything around it, you can kind of get an idea of where it's moving. So that's the radar summary. The radar summary is the one that actually is giving you the details. So if you go into this one, like this side over here, we can see that this one is 50,000 feet and it has hail in it. And then, so the blue actually is the convective segment boundary, or the storm warning summary, like a watch box is what they call them. So let's see here. Let's look at some of these other ones. There's another one that's 5 minutes. So the best we can get is 5-minute radar. So this one here, we don't have the actual, the summary of the height and the movement on it, but this is 5 minutes old though. And that's the best you're going to get, is the 5-minute radar as far as the most recent picture. Let's see here. You have some other ones in here. The next rad. Yeah, on this one you would actually click into a certain area. Like let's click into Nashville, Knoxville. You can actually look at these individual sites if you want to bring them up. You can look at just that one station and just what they're seeing just on their radar. That's kind of what this is made to do here. And this is, yeah, for Nashville. So it's just simply just telling you just Nashville. Let's go back out there again. You can get the winds. Yeah, most of these other ones, precipitation estimate. So yeah, most of this, the big one that you're really going to use the most in dispatch is the radar, because you're always going to be watching real time what a storm system is doing as compared to where your aircraft is flying or where it's about to fly. That's really, the one that you really want to pay the most attention to, and the one that you really want to get the most out of are the radar charts and the radar summary chart of just the movement, what's going on. And this here, I don't think there's one on here that actually shows, let me see if I can find one that actually shows lightning strikes. There's all sorts of like different charts in here, obviously. so much that, like, I mean, I haven't really seen, you know, a lot of them. I mean, you can see in here we've got icing severity charts, icing forecast charts. If you needed to look at thunderstorm outlook, microburst outlook, en route, you know, charts 9 hours from now, like what the wind should look like. But one of the big ones that we use that's already like on our Fusion at work is we actually have lightning strikes. So it looks a lot like this this radar summary chart right here, except when you go into it, you'll see little dots everywhere, like black and red dots, and those are all lightning strikes. So you can see everywhere that has had a lightning strike. The black ones are like 10 minutes old, and the red ones are like within the last 5 minutes. But it shows you like real-time lightning that's going on. So one of the big things about a thunderstorm, one of the biggest issues to tell you how powerful a thunderstorm is going to be the quantity of lightning. So if you're looking at a storm cell and it has no lightning strikes in it, that's going to give you a really good idea as to what you can tell a pilot. Like, yeah, I mean, it is showing heavy rain, but there's no lightning, you know, and that's going to give you a really good idea of the stage of a thunderstorm, because that's going to kind of tell you that this is in the dissipating stage. When you're in a dissipating stage, you only see like random lightning just kind of here and there. Obviously, when it's mature, you see you see a lot of lightning, and so that it'll give you the idea basically of what stage you're in, and if you want to send a plane through there. You don't normally want to send planes into lightning, because when you have a mature thunderstorm, you have a lot of other things, and you have hail, like you do on this one up in the northwest. You have the microburst potential. There's just so many things that are associated with thunderstorms that you have to pay attention to, that you normally always want to avoid flying in or around thunderstorms if you can. So, and we'll talk a lot more about that later, but yeah, that's basically, today was just kind of meant to cover this, the weather charts, but you're going to see all of this over and over again. We're going to look at a lot of this stuff multiple times. So, yeah, that's it for today. Right on time.
When we were talking about the area of forecast, I found a website that pretty much has all the acronyms for it.